What's up, everyone? Welcome back to Better Biomed. Folks, today is finally it. We're going to do this. I've been procrastinating on this for a long time. We're going to talk about the generations of electronics. Now, this is a video that I have thought in my head for the last 30 years of the different generations that I experienced, because I fix a lot of things, guys. A lot of things. And because I fixed so many things, I started noticing that they have certain traits, and I started segmenting them into generations. And when I got into medical equipment, it compounded, because obviously medical technology, they say, is moving so fast. But once you take a look at some of these generations, you're going to be like, they're still making Gen 1 products to this day. And now you're going to see, hey, that's a Gen 2 product. If it doesn't need to be more complex, then why should it be, right? So today we're going to cover the generations of electronics. Coming up next, right here on Better Biomed. All right, guys, we're going to go ahead and get this kicked off with Gen 1 electronics. So this is the first generation of electronics. It encompasses many years worth of stuff. In fact, they're still making them to this day. And you're going to see that they have a lot of these features right here. And if I'm missing some, let me know. And just like anything here, hey, criticism is welcome. Don't be a dick, all right? But this is definitely a trend that I've noticed. So these generations, they are my opinion. I've never seen anybody talk about this online, which is why I'm doing it for you today. All right, guys, Gen 1 electronics. First off, they're all analog, all right? Everything about them. There's no digital monitoring or whatsoever. They're all analog. They run on AC power. Now, if they run on AC power, that means that they probably have the potential to be very lethal, and they probably produce a quantity of leakage, all right? And that's one of the reasons why our medical devices and electronics in general have moved to more safer things, is because less leakage is safer for you and me. So anyway, they're all analog. They run on AC power. They have neon or incandescent indicator lights. This is a dead giveaway. Like when I see neon lights instead of LEDs, it means, oh man, is this whole thing powered by AC power? And that means usually yes. And it usually means that it is a Gen 1 electronic, okay? Doesn't necessarily mean it's old, again. They're normally controlled by buttons, dials, and analog timers. It's true, like watch timers. And it's crazy because I still see, to this day, things like infant warmers that are controlled by a rotary timer. So what happens if that timer jams up, which, by the way, I did see? That means that that baby is supposed to be on a 15-minute timer, and it's just sitting there getting cooked, all right? Analog is sometimes not better, right? They're controlled by buttons, dials, and analog timers. They're adjusted by transformer taps and variacs. So a variac, I might have one around here. It's basically an adjustable AC power source. So you can tune it down, tune it up. You can also change the transformer taps, which controls the voltages. They usually have gauge readouts. We have manual locks, interlocks. So an interlock is normally like a button or a switch that will detect if a panel is there, and it'll usually be a micro switch. And when it is disengaged, then it opens mains and the rest of the circuit is not energized. See this in some of the old light sources, okay? So it will have an interlock on the cabinet, which disconnects the mains. And like I said earlier, they have the highest amount of leakage, right? So they have AC motors, which are controlled by variable transformers. Let's take a look and see what that might look like. Gen 1. I've got some examples here. All right. All right, here you go, guys. So this is a AC powered defibrillator. Oh yeah. Gen 1 product there all day long. See these little guys up here? Those there would be the neon indicators. We got an analog gauge and probably a variac right here, which controls the amount of AC, all right? And we have an old centrifuge. Again, guys, take a look at it. We have neon indicators analog timer, and notice there's no adjustable speed. Gen 1 product for sure. And there's almost definitely right here an interlock, almost definitely. And that's going to be your lid detect. So if your lid doesn't come down, there's no AC power to the control, and there it is. That's the old way of protecting you. Oh, this is a good one. So there's a lot going on here. It looks like a generator. Yeah, okay. So again, analog gauges, neon indicators, and look at this, voltage level, a Variac. Interesting stuff, right? And switches, a lot of clickety clacks in there, some good stuff. Man, anytime I see one of these, I just want to touch some buttons because they got that real firm click clack because it is a mechanical, not an electronic component. So it's actually connecting and disconnecting physical contacts. Oh, here's a good one. All right. So we have a timer and we have a speed control. So if this one's a speed control, Variac, I would assume, and on with timer, off without timer. So it's basically just running it off of this one or this one over here, and brake on and off. So it does have a braking resistor. So that means when the timer runs out, then it will absorb the extra energy, and the induction in the coils of the motor will create a motor brake. So man, that's an oldie but goodie. I've actually seen this centrifuge in person. I love them. Now this one, I'm not really sure if it's a Gen 1. It could be a Gen 2. I cannot see any schematics for this guy. And based on the production date of this ESU, I'm going to assume that this is a Gen 1 product. So there's going to be some sort of oscillators up here probably. But again, you got a Variac and you have a analog gauge, again, neon indicators, nothing special, minimal safety features, if any. There you have it. I assume that this is a Gen 1 product. The Gamco, yes. Guys, the Gamco is an absolute classic. Anybody that doesn't know, the Gamco is what many of us biomeds are trained on in the beginning. Old school right there. Look at that guy. Analog gauges, and it's really cool. I've got a schematic for this guy. I'll show you what it looks like on the inside when we take a look at the schematic, and I should have rotated it. That's okay. You guys can get the gist right here. So we do have our mains coming in, and notice there is no vacuum tubes on this one. There's no rectifying diodes, no nothing, right? So there's no rectification. It's all running off of AC power. And interestingly enough, down here is the timer mechanism, and look at this. Rheostat, right? Interesting. There you go. So solenoids, fan runs off of AC. If you got fans and stuff running off of AC, yeah, definitely a Gen 1 product. So that is the inside of the Gamco. God, I wish I would have rotated that image. Does this guy look familiar? This is, I don't know who owns this photo, but I found this one online in this format. So this is a hydroculator. That's right. They still make them to this day. I believe this is an M4 hydroculator. So right here's your IEC. This is your power input. Notice, again, there's no rectification. Power comes in, it goes into the element, and it actually twins off, and it goes over here to the front light, and it comes down here to the thermostat. The thermostat connects and disconnects mains, okay? And when it connects and disconnects mains via the thermostat right here, so it goes through this guy. If it reaches over temp, then this guy down here doesn't have power, right? And then it returns up here to the element. So right here is the two heating elements, and your thermostat. This right here is a little little tube that's full of pressure, and it controls the thermostat. But yeah, it's all 120 volts AC mains, all on, all off. That's it. Gen 1 product. That's what the hydroculator looks like. You can see the control panel down here. Yeah, simple. Over temp control, that's just resettable. And look at this right here. Thermostat is just an analog spring-loaded dial that it puts more pressure on a little diaphragm, And that diaphragm is actually controlled based on pressure, which is this guy right here. So there's a little spring-loaded diaphragm in here, and all you're doing is increasing the amount of pressure on that spring, which prevents it from tripping early. And that's how it controls its temperature, and it's worked for decades. Love these guys. I've done multiple videos on them. Hydroculators by Chattanooga. All right, and this one here, you guys recognize it? A biggie, a goodie. This is a MagnaClave. This is normally a desktop, although man, it is freaking huge. This is a desktop sterilizer, and guess what? The same thing I've been telling you guys, analog clickety clacks. We got timers that are analog and neon indicator lamps up here. That's right, guys, Gen 1 product. That is a MagnaClave sterilizer. And what's even better is I have a schematic right here to show you guys the inside of MagnaClave to prove myself. Right here are the mains coming in, and look at this, power on off, disconnects mains. Interestingly enough, it disconnects mains from only the hot side, because this is a 240 volt system. So you got one leg of 120, one leg of 120, and then ground. That gives you 240 volts. Open door switch, again, that is an interlock, pressure interlock. Both of them disconnect mains from the rest of the system. And open door light right here, clickety clacks based on the circuit path. It is all AC powered, and these ones right here, notice how they're connected directly to AC mains. Those are neon indicator lights. That's right, folks, Gen 1 product. This is one of those infamous radiant warmer lights, an Olympic light, and there you have it. Same thing, folks. We have an intensity, we got a rheostat, we got a timer mechanism. Right up here is the light, all analog, Gen 1. Oh, this guy right here. This is a radiation therapy. Back in the day, I tried so hard to find some sort of schematic for this guy. But from the image of what you can see, you clearly have output dials. You're probably controlling taps on the transformer in here with these dials, and that's going to control your output of your radiation source. Kind of scary when you think about it. Man, we've come a long way. Gen 1 product. This, folks, is a Zeiss, vintage Zeiss surgical microscope. I have no idea how they utilized it. I see right here, this looks like a light tube, and up here, of course, is going to be your binoculars. Look down here, infamous words, transformer, Gen 1 product, folks. That is all AC powered. And that is it for our Gen 1s. Let's take a look at what a Gen 2 product is. Gen 2, now mind you guys, as we move up the scale, there's going to be more and more items on a generation, okay? It's just the way it is. Things are getting more and more complex and less repairable. Gen 2 electronics, we have a mix of analog and some digital, okay? This is when DC first starts hitting electronics with our Gen 2s. That usually means solid state. It could also technically mean vacuum tubes. We'll find out in just a moment. So it could be vacuum tubes or solid state electronics. Usually a big giveaway is segmented display readouts, okay? A segmented display readout usually indicates that it's a simple logic IC. And here's where we also have simple watchdog circuits, because now we have DC. They can take a look, instead of disconnecting mains, a simple watchdog circuit will be a simple logic that says, hey, if this, then this is going to be the outcome, which usually means, you know, inoperative. It doesn't mean a watchdog like, hey, are all these CPUs talking to each other? Simple with Gen 2. Gen 2 also is full of oscillators and 555 timers. 555 timers are like a dead giveaway. It's a Gen 2 electronic. It doesn't need to be more complex, right? But the good thing is these parts are readily available, and usually it is very repairable. These things are normally calibrated with potentiometers. Back in the day, when you had a pot tweaker tool, Gen 2 electronics. We also are known for having jumpers and dip switches in Gen 2s. You got to change dip switches to get into a service mode, or you got jumpers that you have to activate. Gen 2, usually. So Gen 2 is also, it's full of through-hole PCBs and some surface mount. Some of the later Gen 2, like I said, all these devices are still being made to this day. A desk lamp could be a Gen 1 product if it's AC powered and uses an incandescent bulb, could be a Gen 1 product, right? But if it's got a motion sensor and an LED, it could be a later generation, all right? They still make them to this day. Through-hole PCBs and some surface mounts, all right? Not too many surface mounts, a lot of them are through holes. Controlled with switches, knobs, and buttons. All right, switches, knobs, and buttons. Notice I didn't say like rotary devices and rheostats and variacs, okay? It's controlled with switches, knobs, and buttons, and a lot of those are digital functions, all right? So a digital function means that it is a logic that goes back to the logic controller. Maybe it resets the 555 timer or something like that, but it is no longer switching mains. So Gen 2 is already safer because we are not running mains throughout the whole device. Mains on motors and whatnot is what creates a lot of problems. Although Gen 2 often still has AC motors. So you'll still have a lot of AC motors for like drives. If you got to drive a device from point A to point B, it's usually an AC motor, and often, one speed. So remember that, guys. And another big indicator of Gen 2 products is that they usually have lead acid batteries. If it's got a lead acid battery, it's probably a Gen 2 electronic, all right? So let's go ahead and take a look at some Gen 2s. All right, guys, Gen 2. We're going to start this one out with a schematic so that you guys can see what I'm talking about when a device is a Gen 2 product. All right, so Gen 2 is going to be simple. It can be solid state or it can be vacuum tubes, and this is the perfect example right here, guys. I've got a vacuum tube schematic here. This is an old radio, by the way, and you can see right here we've got the mains that's coming in over here in the lower corner, and yep, we got the 35Z5. That is a vacuum tube right there, and that is going to rectify, and it's going to come over here, and you're going to see we have 150 volt, 150 volt, and 200 volt. And these capacitors right here are your smoothing capacitors for that output high voltage DC. And look at this up here. We got a 90 volt battery and a 9 volt battery. How crazy is that? So we got a 9 volt battery, which I'm assuming is control, and we've got 90 volt battery, which is probably operating. But this guy here, it looks like it is a radio. It's got an antenna, amplifier, oscillator, and a loudspeaker down here at the output. Yeah, it looks like some sort of radio to me. Holy cow, guys, this is Gen 2 all the way. And this is old school Gen 2. This is back before solid state because they still had a vacuum tube. This is before we had diodes. So here you go. This is a Gen 2 product. All this up here is all DC. Now, early ones didn't have really good filtering on the capacitors and stuff, so they did have some leakage, especially when you got some of these oscillators that are just going nuts. However, vacuum tubes also create a bit of leakage. And that's why we moved to solid state, right? So guys, Gen 2 product right here. This is when you start segmenting devices between AC power and DC power. Okay, so AC is down here in this bottom corner. This up here is all DC. And you're going to see this going forward, all right? AC is just at the input, and then it goes into usually some sort of switch mode power supply, which isolates mains from you, the user. So anytime you isolate mains from the user, you're creating a huge barrier for safety. And that's what we're doing here. And that also allows for digital controls because digital requires DC, right? So there we go. First one. Now this one here, I don't know the inside of the control box right here, but this thing is spelling to me Gen 2 all the way. We've got simple controls down here. So these are going to be I don't know if it's going to be an analog signal, whereas you go left and this might be like an 8-pin wire. So these are just double rockers. This could be a digital controller, which means this would be a Gen 3. I would have to look inside the box right here. But this one here, to me, is saying Gen 2. So what we'll have is a focus mechanism, which is controlled down here by the foot control, but we can actually do that very easily on a Gen 2 product. So all you're going to do is control the motor one way or the other, but if it's got autofocus, any sort of autofocus is going to be Gen 3 to Gen 4. So if it doesn't have autofocus and it's just controlling the focal in and out and the zoom in and out, and even the intensity of the light, Gen 2. I'm sorry. So I'm going to put that one square in that. This might be a digital controller down here. If it is, Gen 3, but we'll see. Oh, this is going to bring back some memories, guys. Okay, mind you, I said that Gen 2s are still being made to this day. Why? Because if it doesn't need to be more complex, then why? So this guy right here does have a controller, and the power does come in. It does convert it to DC, although some of the functions could be AC, like a heating element, right? So you have a digital controller that is going to turn on the heating element for both chambers, which the heating element is going to be interrupted by a door detect switch. So that could be either AC or DC. It could be an interlock, or it could be a DC signal that just tells the controller, hey, disconnect. It could be either, but this is a Gen 2 product all the way. You have just a little bit of DC it stripped off, and then you just have a simple logic controller on this type of thermal cabinet here, Gen 2. Yeah, like I said, we're gonna bring back some memories, guys. Look at this. We have an old Eagle, Amsco Eagle. Man, these guys are workhorses. Simple logic controller right here. And a lot of the other functionalities are gonna be controlled with AC. So we got the guy that comes in here. It's going to strip off some DC, and that's going to power this little guy right here, mainly for the little printer. That's the biggest thing in this guy. So yeah, it controls the cycles and the timings and whatnot. The little printer right here is the guy that is phenomenal. That's what it needs in order to keep track of those cycles. And that's why this guy went digital. The old Eagles, man, this guy is probably 20 some years old, maybe even 30 years old. It's, man, brings back some memories. Love it. Now this guy here, this is another one, which could be Gen 3, could be Gen 2. And now it does technically have a little computer, but the computer could be just a simple logic controller or microcontroller, because all it's really doing is a math based on an input. And it's got very simple controls down here. And the simple controls, it's basically a calculator. It calculates and it spits out this. I would have to look inside it, but at the moment I'm saying Gen 2, could be a Gen 3 because it's got an integrated computer. Could be a Gen 3. I don't know. This one's kind of old. I'm feeling Gen 2-ish. Could be a Gen 3 though. Again, you know, you're going to see a lot of similarities in these products, and there is going to be some overlap. So this guy here is a centrifuge. Guys, this is a centrifuge. I showed you a Gen 1 centrifuge. Now this one here, all day long, is a Gen 2 centrifuge. So this one here does have AC power in, but you can see that it has a very simple logic controller. This guy here is probably based on a 555 type timer, because all you're doing is you're selecting this timing or this timing. That's all you're doing on this guy. So 2 buttons, and there's going to be a little rectifier in there. It's going to rectify the AC power. Now, the motor could be run by AC power on this guy. Again, I don't know, but judging from the image and from what I've seen, this guy here looks like a Gen 2. Now, if the motor runs off PWM and stuff like that, then it would be a Gen 3. But to me, this guy here is probably a Gen 2. Oh, yes, the Force 2. Now, this guy here could also be a Gen 3, okay? Now, hear me out. Inside here, there's a whole line of potentiometers that you have to calibrate, right? It is a very analog process where you have to have a multimeter and oscilloscope. Calibrating the Force 2 was an absolute pain in the keister compared to the ones that we're going to cover later on. These guys here, it was a very analog process. That's why I'm putting it in a Gen 2, because these guys were literally stupid. You choose a function right here, and it does change some oscillators and stuff inside, but don't count on any help whatsoever from this guy. Very simple watchdog circuit, very simple just all around. And it does have a very simple REM monitoring right here. We'll get into some more advanced ones. I'm saying Gen 2, could be early Gen 3, but the Valley Lab Force 2, what a classic. Oh, man. The EB audiometer, this is the Model 60 Extreme Bros. Many of you guys probably haven't even seen this. This spells Gen 2 all day. Big indicator is right up here. You see how it says battery? Battery means it's running off of DC. 100%, this is a Gen 2 product. Big clickety clacks right here to choose your different functions. And right here, look at, we're going to control the frequency and the attenuation, the decibels over here. And it's going to be calibrated probably with potentiometers on the inside. I tried so hard to find a schematic of this guy, and I just couldn't find it. So old audiometer, almost definitely it's calibrated with POTS. Gen 2 product. Oh man, here's an old physio control. Now this one here, I'm saying is a Gen 2. I'm saying a Gen 2 because this one here is one of the stupidest defibrillators. Not stupid as in derogatory, but it's not smart compared to modern day defibrillators by any means. And the old indicator lights, most of this guy here is going to be running DC, but I'm guessing it's based off of simple logic timers and stuff like that. And maybe a couple op amps. So anyway, that's an old physio control right there. Good stuff. You guys know these Welsh Allens? It's battery powered, but we have an AC coming into the base, charges the batteries on these. Gen 2 product all day long. These guys here are actually running off of DC. Base is AC, it rectifies. That there's going to be a Gen 2 product. Oh man, the Parks Doppler. Guys, the Parks Doppler. This thing's a classic. And to my knowledge, they still make them to this day. And they definitely repair them, at least to what I remember. So all this guy does is it sends out an acoustic signal on this 8 megahertz probe on this model. And it's going to bounce it back. And you will hear it here. There's some op amps, some amplifiers. Again, right here, we have a power supply coming in. It goes in and it goes into some DC circuitry. So AC to DC, no microcontroller. It doesn't have to be that complex. So this guy here is a Gen 2. Ooh, you guys, so these guys here, this one I'm going to guess that these are mainly analog type of switches. They're up, up, down, down, and when you get to a limit, that's when it's going to disconnect. That's what I would assume, because that would be the cheapest way to produce it. You know, that's manufacturing in a nutshell. Doesn't need to be digital by any means. Some of the more modern ones will show you the level of incline and stuff, and they're very fancy. Not this one right here. This one here doesn't even have presets, okay? Presets are kind of an indicator of like a Gen 3. Nope, no presets. It's stupid from what I can tell. That's why I put it in Gen 2. Oh, here we go. Striker. These Striker, I don't even know if these guys are being made anymore. It does have a digital scale, and in that way, it kind of could be a Gen 3 product. But listen to me, guys. It comes in, and it's stupid. This guy is really stupid. It just, you push on it, and it wants to drive. See that button right there? You push that button, and it wants to move forward. I don't see any bump stops or anything. There's no real protection. You could run over somebody's foot. It's not intelligent by any means. I'm putting this as a Gen 2. And it might have a microcontroller in it that's reasonable, only for motor speed control. But again, it's going to be as stupid as possible because it doesn't need to be anything more. And the most intelligent thing on it is going to be the little scale, if this guy does have the scale option. I'm saying Gen 2. All right, guys, so that's Gen 2. Let's go ahead and let's take a look at what comprises Gen 3. Gen 3 electronics. I told you the list is going to get bigger. It's going to get bigger. And that's because they're getting more complex and less repairable. Gen 3 electronics, mainly DC. Big indicator right there, mainly DC. And that's also why some of the previous products that I talked about could be Gen 3. Mainly DC with some AC functions, like heating elements and motors, of course. more complex logic controllers and microcontrollers. Kind of a big step. Internal self-checks on power up. That's a big one. Now we've moved into the realm of devices that check themselves to make sure they're safe. Calibrated with digital gain and pulse counts through a logic controller. So if you press buttons to calibrate something, that's a big indicator it's a Gen 3. The old ones, you used to have potentiometers or something like that. No, not these ones. It's digitally, and then it saves the settings. Very cool. Now we have watchdog circuits, okay? These are the more advanced watchdog circuits where it's like chips talking to chips. Now, some of the older ones, like I said, were only simple logic watchdogs, which are like, am I okay? You know, and it might be just a DC signal that goes around, and maybe ground is detected or not detected or something, and it'll throw an error code. But this one here is going to be real watchdog circuits. That's when the CPU goes out and it talks to all the components that it can, and it says, are you okay? Can we talk? Can we talk? All right, that's your watchdog circuits. Big one for Gen 3, error codes. When we started getting error codes, it meant that now we could fix things easier than ever, all right? And it used to be like error codes were really generic, but now we have some error codes that can kind of tell you exactly what's going on, like high voltage on PS2. You know, we could say that there's a communication error on board 3, stuff like that. That's because we now have microcontrollers and they can do many things. So error codes, big one. Electronic safety locks. I said earlier that there was going to be a lot of analog safety locks, maybe even just DC power breaks. Now we have electronic safety locks, which are like, it might be the pin is high at the microcontroller, and then when it gets a response, the ground comes up. And that would be a logic type of safety lock. Or the missing negative. So if one of the micro switches is activated, that ground that goes back to the CPU might be broken. So the pin at the CPU is now high. Now that would be an electronic safety lock, and there are all sorts of them. I could list off, I could do a whole video on just types of safety locks that you'll find. LED indicators. Okay, now there are some LEDs in Gen 2s, all right? Still a little bit early. You might see some of the red LEDs and whatnot, but LED indicators are a big clue that something's a Gen 3, okay? Because that usually means a full-on switch mode power supply. A lot of Gen 2s will have maybe some rectifying diodes or maybe a full wave bridge rectifier, but not a switch mode power supply. So in this case here, Gen 3 electronics, we're definitely talking switch mode power supplies, almost guaranteed. So we have LED indicators. It's controlled by physical buttons or touchscreen. Again, it is no longer touching the mains at the button. Now what we are doing are going to be like soft on switches. So there's going to be a standby signal that goes to your power supply, and you hit the on button, and now there's a little standby signal that turns the power supply on. So that's now Gen 3, okay? We have digital sensors that provide input to the logic controller. So now we can have machines that start making decisions. Now we could before because we had logic controllers, but now we got digital sensors that are constantly providing feedback. And at this point, the frequency, the refresh rate of the microprocessor is so fast that it can make corrections or throw error codes faster than you'll ever know that there was even a problem. So that's Gen 3 electronics right there. Servos and stepper motors. So servo is a motor that knows its speed and or position, and it can position itself accordingly. There's a feedback loop. And a stepper motor is a motor that's got high resolution, and it can index itself based on pulse and direction. So it's really cool when we start getting into stepper motors and whatnot, because that means that now we can control things and we can monitor things like current. So when a motor is contributing a little too much energy, current monitoring means that maybe it's reached its limit instead of using a limit switch, we can do current. Or, maybe you can protect an entire assembly because now we're monitoring the current of the motor with a feedback. And that means if you have too heavy of a patient, or maybe you are bumping into a wall, so now the drive motor has got an instant load, it knows that, whoop, I must have hit something, and it cuts out. So pretty big right there. Now we have feedback to a logic controller. Servos and stepper motors mean that we can now control movement with precision. So generation 3, usually this is where they start being controlled by an external PC or by a computer. So before we had logic controllers and stuff, now we have computers, or what we would call a computer, controlling the device. And often this is where you'll have something like a treadmill, but it's controlled by a computer, right? The treadmill itself is stupid. It's just an accessory, but it is controlled by the computer, and thus it is a Gen 3 electronic. Usually Gen 3s are SMD PCBs, which means surface mount. The through holes, the days where you're putting resistors through and soldering from the underside, those days are over usually with Gen 3s. Gen 3s, it's almost all surface mount, and this is when they got into manufacturing to scale. So we have also digital dip switches and jumpers. Digital dip switches and jumpers. So now is when you can go into service mode or into a Biomed mode, and you can set certain jumpers, certain parameters, like instead of kilograms, now you're going to pounds or something like that. That could be a digital jumper, a digital switch. Versus old style scales, we would physically have to move a jumper on a PCB, and that would now change the functions of the software. Since I'm talking about software, Gen 3 is where we have software-based license options. This is when you start getting the licenses that you have to buy in order to have the full functionality of the device. It's the downfall of electronics as we know it. It pretty much happened with Gen 3 electronics. And, there's no going back. It's inevitable at this point, software-based license options. In order to have full functionality, you got to spend that money. This is also when we started seeing a change in battery technology, okay? A lot of them are the nickel metal hydride, and some of them are still lead acids. But that's usually because of capacity and the amount of current draw that they need. However, this is where we start seeing lithium batteries, right? But nickel metal hydride and lead batteries, this is a big indicator it's a Gen 3. So let's go ahead and let's take a look at some Gen 3 items and see what they should look like. All right, guys, Gen 3 medical devices, or Gen 3 electronics in general. Let's go ahead and let's keep up the momentum with centrifuges. Centrifuges have been around forever, and I think they're just a fantastic example of each one of these steps. So with a Gen 3, microcontroller controlled, which means now we can control the pulse width modulation of the motor. We're not running off AC motors anymore, almost certainly not. Usually this is where they step into 3-phase motors with brushless motor controllers and stuff. And we also have a digital timer right here. So timer sends a digital signal to the microcontroller that tells it, hey, shut off. And over here, we have active RPM monitoring, probably because we have a feedback loop on that 3-phase motor that's in there. And that brushless 3-phase motor is going to give it a constant RPM. So it knows to increase or decrease current according to the load. So it's going to need less current to achieve the same RPM if you have these half empty or if they're completely full. And this is where things really get interesting, because we have the realm of precision now. So there is a microcontroller in here. We have digital time, digital RPM, and all sorts of error codes and whatnot. And this up here is no longer an interlock. It is a door lock, but it's now a digital one, which digitally tells this guy here to not turn on. So interesting. The Codman, guys, the Codman. How crazy is this guy? It is microprocessor controlled, and the Codman, what a workhorse, man. This guy here almost makes me feel like it's a Gen 2. LEDs, this guy here, it does have like a bunch of error codes and stuff that can pop up, but This is early Gen 3 days right here. Segmented displays also kind of show its age of where it's at on the pipeline. So like I said, this one here could be a Gen 2, but I'm going to go ahead and go with a Gen 3. You can see down here, it does have different audio tunes and stuff that come out of it. So this guy here, it does have a microcontroller inside it. What a workhorse, the Codman CMC3. You guys remember, you ever open up one of these argon plasma units? This is a Codman System 7550, and these guys are absolutely intense on the inside, right? So the AC power comes in, it gets rectified, you got some high voltage boards and you got some frequency boards and stuff in there, and it is absolutely intense when you open it up. I tried finding images of the inside of a 7550 because I absolutely love going through what's happening under the cover. There's a screw here and a screw here, and it lifts up. I consider this one of the last greats when it comes to medical equipment because it was serviceable. You could lift it up. It was designed to be repaired per se, and you could get in there and you could fix problems. I've fixed many problems on these. Microcontroller base, they do have segmented displays, but it does have like active port monitoring and stuff, and it does have a lot of like error codes and stuff. But man, that's a 7550. What a classic. The Force FXC. Now, you guys, earlier I went over the Force Easy that used potentiometers. Now this guy here does have one potentiometer that's on the inside, but for the most part, this guy here is controlled digitally through the control panel right here. And that is through soft switches, up, up, down, down. You get into the service menu, and then it will give you a code across the 3 displays that tells you what menu you're in. And then while you're monitoring with your meter, you press this right here to adjust your offsets. So this one here is Gen 3 all day long Force FXC ESU. Amco, is that what it is? Is that Amco? Anyway, the Amco audiometer. So this guy here is a Gen 3 device all day long. It's powered off of DC. In fact, you can see the DC adapter coming in. Very simple, very, very simple, guys. So we do have, see, continuous pulse and warble. So it does have a bunch of functionality. That means it's going to have a digital controller inside that's going to monitor itself and whatnot. It probably also has a self-check when you power it on. And yep, right here, auto test. And look at this, a fail, pass, ready, in progress. So the fact that it's got a fail right here, that right there is interesting. I've never used one of these, but this guy and this guy right here, almost certainly Gen 3 all day long. I love it. Guys, come on. You should be like screaming out the names of these as I enter into them. This is a Steris 3080 or 3085. And what an absolute workhorse. These guys are still out there in mass all day long. The AC power comes in right here. There is a rectifier and it goes off, and there's batteries and a battery maintaining circuit, and there's a microcontroller right here on the column. And this guy is a Gen 3 as they get. All right, what a workhorse. But there are a couple PCBs up and in here that control the functionality and stuff. Still very simple, very Gen 3. And just to prove it, take a look right here. I have a little schematic of that Steris. Now this is a Steris 3080, but you get the point. So right here's my mains coming in, and it goes into a power control assembly. Okay, so when you have a power control, that is usually what we call a switch mode power supply. And what it's going to do is it's going to rectify the AC, turn it into DC, and it's going to also output various forms of AC and or DC for the various components. This guy right here, notice how it's right next to the table control. And let's see, what do we got up here? We got some little transformers, is that it? And you can see right here some batteries. So we have the batteries coming into this right here, so it's also your battery charge circuit. And yeah, Gen 3 all day long. It's not that smart, but it's not stupid. You know, it tops off those batteries accordingly, and it knows when it's reached its limits and whatnot. But Gen 3. Ooh, what do we got here? This here is an old Steris sterilizer, but not that old, because it clearly has a controller right here, and the controller is going to print out. We do have the analog gauges. I love some analog gauges because you can walk by and see if there's any anomalies. And there's sometimes an AC motor on this one here. It might be a DC motor, which is controlled by this up in here. But guys, this is a Gen 3 sterilizer. And so we showed you what a Gen 2 sterilizer. This is a Gen 3. And that little controller right there, it's smart, but it's not too smart. There's smarter ones. There's definitely smarter ones. We'll show you. But yeah, this is a Gen 3 product. And for the most part, it does the job. Not the most efficient thing out there in the world, but it does the job, and it did the job for decades, right? And that would be the end of my examples for Gen 3. Let's go ahead and let's take a look at what a Gen 4 is. Gen 4 was like the top of the top, all right? It's not the last one. There is a Gen 5, but Gen 4 for most electronics is like the top of the ladder. So let's go ahead and take a look. I've been saving for this moment because Gen 4 electronics is where it's at, guys. Gen 4. This is where there is, for certain, some level of what we would call an integrated computer. Okay, there's some sort of computer inside it that controls the thing, and it does other stuff. A big indicator that something's a Gen 4 is it's now part of an ecosystem. You have this component at this facility, or maybe even hundreds of miles away at another facility, but they talk to each other. And they talk to each other and they perform a function, or it's centrally monitored from some other place. Big indicator that something's a Gen 4. Active monitoring of multiple systems. And this is where they are what we call an ecosystem. You know, this is where you buy into one component of a manufacturer and you have to buy all the other components. In other words, this one doesn't work right. Gen 4, all day. All right. This is also where you get into monitoring for consumables. Okay, Gen 4. This is a sensitive topic, guys, because Gen 4 is when we introduce consumables monitoring. That means that the device, if you don't have the right consumable, it will not do its job. All right, that means that often manufacturers make you buy their consumables. And this is where they figured out that that's where the money's at. All right, no longer making a product that can use any type of consumable. We're going to make a product that uses our consumable, and then we're going to patent it, and we're going to make it so it's proprietary. Gen 4. Okay, consumables monitoring. But at the same time, Gen 4 is also where you have some things like certain types of ESUs. They detect what type of component is connected to it, and certain functionality is going to be inhibited based on what you have plugged in. But that also means that if you didn't buy certain license options and whatnot, it ain't gonna work. All right. This is where the devices are usually networked. If it's networked with anything else, Gen 4, usually, almost always. Bluetooth capability. So if you have a wireless component that talks to the device, it is almost certainly going to be Gen 4. Now there could be some Gen 3s that use like RF or infrared to communicate between point A and point B. But Gen 4 is almost always going to be Bluetooth. All right, that means that it doesn't have to be line of sight. So infrared has to be line of sight, which means you have to be able to see the receiver in order for it to work. And RF is a whole different thing. We don't really like RF in a medical setting because you're introducing radio frequencies in an environment that's already like, it's just full of radio frequencies, like various wireless devices, medical networks and stuff. In medical, we do not like having devices that communicate with RF. Whereas Bluetooth, it's a very constrained and very regulated protocol. So almost all Gen 4 is almost completely DC. The AC comes in and it immediately splits off to DC. You will never see like AC motors running in a Gen 4 electronic device. Just doesn't happen. And because of that, you have extremely low leakage, right? We also have DC PWM motors, which means we control the speed and positioning of the motors using microcontrollers. So PWM has changed the game. That means now we're using brushless motors instead of brushed. Brushes actually create a lot of noise, like not just like audible noise, but radio frequency noise. And that is really bad in medical environments because radio frequency noise can induce itself into neighboring devices. So we do not like that. Gen 4 has made things incredibly safe. And Gen 3 progressing to Gen 4 is why a lot of people are starting to talk about whether or not electrical safeties are even valid anymore, because we got Gen 4, some Gen 5 products, but a lot of them are Gen 4s. AC comes in, it splits off immediately with a regulated DC power supply, and you're completely disconnected from mains. So leakage is not what you think it is anymore. So it has the lowest leakage out of all, except for Gen 5. Gen 5 doesn't have any leakage for the most part, but the lowest leakage out of all the previous. A big indicator of Gen 4 electronics is there are software and security updates. Okay, yes, there's software licensing options, but now you have to regularly upload software to keep your device current. This is a big one for Gen 4. That means usually you have to have some sort of subscription, okay? And you have to have the OEM touching your device, usually, okay? So Gen 4 is also when we get into like flat rate repairs and stuff because only the OEM can touch the device. There's also digital calibrations, and we usually do not have access to those digital calibration screens. Like I said earlier, they figured out about consumables. They also figured out about locking out technicians from getting in and doing their own services. In a world where storage, digital storage is now very, very cheap and very, very easy to create these graphical user interfaces, things that are very easy for you to interpret versus back in the day when you had potentiometers and you had a checklist and you had to follow it step by step or else it's going to fail, maybe burn somebody. Nowadays, there's watchdog circuits and stuff that monitor the amount of energy and leakage and stuff, and they know if it's safe or not safe. But they've clamped down for the sake of glorious money, and they have prohibited people from getting into most Gen 4 service menus. So there are digital calibrations on these. However, we don't have access to them usually. There's internal self-checks and constant system monitoring, high frequency system monitoring, like thousands, if not tens of thousands of times every single second. It's saying, are you okay? Are you okay? Are you okay? Am I okay? Am I okay? So these devices, they are constantly monitoring. If there's anything they don't like whatsoever, it will throw an error code and all stop. And then you have to ship the device out to the OEM because they're the only ones that can solve the problem. You'll get error codes, but you'll never know what those error codes mean because they're not going to tell you. All right. If you can't tell, Gen 4 is like the way the world has worked, and it's bittersweet. So we have almost entirely solid state electronics at this point. Gen 3, most of them are solid state, but now Gen 4, 100% surface mount and solid state electronics. Everything is about making it smaller, lighter, more easy to manufacture. And this is also when we started to institute planned obsolescence. All right, planned obsolescence is a big one. So planned obsolescence is when a manufacturer determines when you are going to stop using their equipment. Okay, I did just say their equipment because when you have software and it requires updates and you have consumables that you can't obtain other than through the OEM, they determine when you quit using that equipment, which makes it their equipment because they determine when you can and can't use it anymore. This is going to be up for debate, and I'm sure some people are going to give me some garbage, especially people from some of those large manufacturers out there. But what I'm stating is facts, and planned obsolescence is a thing, and we just got to deal with it, right? At the moment, right to repair. One of the other things for Gen 4 electronics is that almost certainly you're going to have lithium batteries from this point. It's just the energy density and the weight of the batteries and the form factors of the batteries and the fact that we're making devices smaller. Since we have to make them smaller, we have to make them lighter because who wants a heavy ass small device? So lithium batteries is what you're going to find in Gen 4 electronics. Let's go ahead and take a look at Gen 4. All right, guys, Gen 4. And I got to start this one off with the king of the Gen 4s, the Alaris. The Alaris Medley. It is an ecosystem. They all interface, they network, right? It's been around for like 20 years. But in that 20 years, there's been different iterations and the product's improved itself. And you've got computers and the pumps, and you got computers, and right here, we actually call this one here the brain. But now they got wireless on them, Wi-Fi, they network, just crazy. The Alaris system is the epitome of a Gen 4 device, right? And I don't know, do these ones have lead batteries? I don't know if they do or not. There's a big ass battery on the bottom. It could be a lead acid battery in a weird form factor, but it could also probably be lithium, right? I don't know. You guys let me know. All right. Autorefractors, keratometers, etc. Gen 3 and Gen 4 is when these things took huge leaps of improvement. And now we've got them that are computerized, they're networked, they monitor a whole bunch of stuff, and they do require software updates, and they also require license options in order to have all the functionality. And wouldn't you know it, they also have the ability to not be serviced by your average everyday Joe Schmo like myself, because we are not specially trained and thus we're incompetent apparently. And this guy right here is clearly a digital autorefractor, and it's measuring the eyeball. And you can see right here, it's got your measurements for the eyeball. It's got a computer. It's got networking down here at the bottom where you can also include a printer. This guy here is a Gen 4 product for sure. This is not just your grandfather's centrifuge. Again, we're staying with the centrifuges. These guys here can be networked now, and centrifuges can do some crazy stuff. You can have user accounts that keep track of runs and stuff like that. So centrifuges and laboratory equipment in general is like leading the pack when it comes to Gen 4 products. They're getting more and more networked, and they're being centrally monitored from some other bean counter's desk. It's just crazy stuff. But what used to be a device that would sit in the corner and get used and abused is now like a center point. Like laboratory equipment is just completely changed in the last 20 years that I've been doing biomed work. And it's so cool to see that evolution. And this one here is a Beckman Coulter Avanti. One of the most advanced centrifuges I've ever seen. Notice the integrated computer. It can network, it can do all sorts of stuff. It's just a centrifuge, right? No, it's not. So that is how the world is. So laboratory equipment is leading the forefront of technology. Gen 4. Of course, I couldn't have this list without a Da Vinci robot, right? A medical robot. That's what I'm talking about. You have a physician's console right here. You have a center console right here. This guy here is the controller, and you've got all sorts of stuff. So the Da Vinci robot, which is this guy over here at the side. This guy connects here, this guy connects here. So this guy here is the big granddaddy that controls everything, and it often has an ESU in here, an electrosurgical unit, and you'll have multiple consoles that connect into here with fiber optics, which is pretty cool. So Da Vinci robot, yeah, there it is. Very complex piece of equipment, and that's one device that I am actually kind of fortunate that it is a Gen 4 device. I do not want to touch it. I never want to touch it. There's just so many calibrations on these. They have servo motors at every single knuckle. They have force sensors on them. And like even right here, even these drivers right here, you've got servos right here, right here, right here, right here, right here, right here, and then up here. So these things are crazy. And then you got drive motors down here that are also force sensitive and whatnot. So, and that's only the robot. We get in the console, we got force feedback. We got force feedback here at the physician's hands. So it knows how much force you're putting on this utensil right here. Right here, you can feel it. So there's a tactile response, which is another reason why we have the fiber optics that connect everything, because we need that high bandwidth in order to have that feedback. But look at this, we also have a stereoscopic camera. 2 cameras, stereoscopic, you can see things in 3D. This is one of the things that I am most proud of in my career, to see this come to evolution. I've seen some of the early surgical robots, which still were pretty cool, but then you see something like the Da Vinci turn into what it is today, and very, very impressive. Gen 4 all day. Now we've talked about ESUs, we've showed several examples, and now I'm going to show you guys a version that I've never seen in person, right? But this is clearly a CPU-based ESU, right? This is going to be part of a rack. It's going to be part of an ecosystem. You have, what is this, insufflator down here? Is it? No, yes, no, no. I don't know, guys. It says endo, so that's not an insufflator. Or is it? I don't know. It's crazy. It's in metric regardless, but yeah, so up here is an ESU, and it's got a whole bunch of different features and whatnot. And there's obviously going to be different types of feedback over here. It's going to be active monitoring, and these devices talk to each other, and they talk to other control items. Very cool when you see some of these modern day surgical systems. They have the camera controller, you've got the light source, you've got the ESU, and a fluid management system and stuff. They all sit there and they talk to each other. So this one here, if this one here increases, like you increase the temperature on your bipolar, it increases the fluid management system, the flow rate and stuff to cool the tips. It's so cool to see that happen. But at the same time, again, that watchdog there saying, are you okay? Are you okay? Are you okay? It's checking to see if it's accurate and if it's serviceable every single second that you're using it. Cool stuff. Never seen one of these in person though. I couldn't do this list without modern day hospital beds. This is just like centrifuges. You can go back to the earliest stretchers and hospital beds, and they're stupid. They did nothing, little to nothing. But nowadays, you got ones that are networked, that are constantly connected to the nurse call system and whatnot. And it's part of this giant ecosystem where the beds talk to the nurses, and the nurses talk to the beds, and you can get active feedback on your patient. It's just crazy what hospital beds are able to do. This is amazing technology, folks. This one here, it can rotate your patient and whatnot automatically to prevent bed sores. It's got active monitoring. It knows how much your patient weighs. So if your patient's starting to lose weight because they're not getting the nutrients that they need, or if they're peeing a little too often or something, you can keep track of that. So cool. Modern day hospital beds. They're networked. They are smart, smarter than ever. And you can drive them. They drive around the block if you wanted to. You got drive handles and stuff. So cool. Hospital beds are a perfect example. Gen 4 product. Pyxis. The Pyxis. So a Pyxis is basically a glorified vending machine for all you non-biomeds out there. And that means you come up and you scan your ID, which gives you a certain level of access. Like if you're allowed to give out narcotics or not, then your clearance will be in there. And then you have to scan the patient's ID, which this adds a next level of cool, because if the patient has got certain conditions or they're taking other certain medications and you scan a certain type of narcotic or a conflicting drug, it'll say, boop, can't do it. And this system right here is monitored and actively controlled by the pharmacy itself. Remote monitored system, computer controlled, all powered with DC Gen 4. There you have it. Pyxis. So earlier I talked about a couple different types of sterilizers, and guys, here we have it. This, in my opinion, is a Gen 4 sterilizer. We have a computer that is controlling it. It is networked, and when sterilizers became networked, it changed the game, because now you can centrally monitor them. You can see everything from a central console. They can be centrally monitored, which includes by the OEM if there's the servicing partner. So if you are having it serviced by somebody and they see how many cycles you're doing, now they can get into predictive maintenance, which means they know that this device here has been used a little more frequently than not, and that means that it's got to be serviced with a closer interval. That's one of the advantages of Gen 4 being networked, is you can see usage, and that helps you with your maintenance cycles. Very cool sterilizer. Never seen one of these in person, but clearly a Gen 4 product. So this one here, this is a Pentero by Zeiss. This is a neuromicroscope or a surgical microscope, and this one here could be a Gen 3 or a Gen 4. I'm leaning towards Gen 4 because it does have a computer in it, even though it's an older computer. It's not really networked per se, but it is an older computer. And there are a bunch of options on these, so I suppose maybe one of them could be networked. I don't know. If you guys know that, let me know. I've never seen it happen myself, but anyway, because it's got a computer and maybe because it could be networked, I'm putting this at a Gen 4. Could be a Gen 3 though. It does have a lot of electronics up here in the head. This is a $250,000 microscope when it came out, something like that. They're incredibly expensive. They still are to this day. Very expensive microscopes, still workhorses. I've done videos on these and everything in the past, but there's a lot of electronics up here in the head, and it's got an active balancing system down here. You can see it. So Pantero microscope, I'm going to put it in Gen 4 because it's got so many advanced features, even though they've been around for many years. It does me no good to have old microscopes if I can't have a new one. All right, this is the new Leica OHX, and networked microscopes, man, this one here is one of the top ones out there. I don't even know how much this guy's, it's probably very expensive, extremely expensive. Again, license options, networked so that people that are even like rooms down the hall can see the video system and whatnot. Very cool. That's right. These microscopes have video cameras and stuff up here in the head, and you can transmit the video. Does some cool stuff. Active balance system down here, CPU controlled, and these microscopes are so cool. Gen 4 for sure. Anyway, guys, I think that's the end of Gen 4. Let's kick this off with Gen 5. Gen 5 are the smallest products of the bunch, and it's also one of the fastest growing categories of generations of electronics. Let's get into it. Gen 5, guys, Gen 5. This is it. In my book, this is the top of the generations, and these are very complex devices when you think about it, but at the same time, they're also some of the more simple and easily the safest devices out there, because these ones here almost don't connect to mains at all. It's almost completely battery powered, and they usually have some sort of app for a phone or something. Gen 5, these are the Internet of Things devices, so IoT devices. They need the internet, network access, or these type of products need some sort of app to control them or to use all their options, right? So Gen 5 electronics, they're mass produced. There's no getting around that, right? They're mass produced devices, and that means that, you know, the failure rate might be a little bit higher than on other ones fresh out of the box. Who knows? Depends on the manufacturer, but these ones here are mass produced. Subscriptions for software, consumables, and added functionality. Now that's a very growing trend. So if you have an ECG monitor or something like that, well, you got to buy their $15 a month plan or whatever. There's almost always some sort of subscription, an app that you have to purchase, or some sort of added functionality that you have to buy into. They're usually mobile app controlled. This is it. You have this supercomputer in your pocket, and it can actually do predictive stuff, but when it's linked to servers and stuff on the other side of the internet, it has a whole new realm. You could even connect it to doctors on the other side of the world through this magical little device right here. And in doing so, you have access to resources you never had before. That's one of the biggest pluses about Gen 5 electronics. They're safer electrically, yes, but you also have access to resources that you've never had before, because these ones here use mobile apps. They're also AI and predictive. AI and predictive. So if you have certain conditions, physiological conditions, it monitors that, and if it sees a growing trend, positive or negative, it can give you some sort of input. If you're working out a lot and you're wearing one of these devices and it knows that, it might know that you're dehydrated, or it knows that your heart rate's too high, or it sees a blip in your ECG trace and it knows, oh, you're starting to get a murmur. They are AI and predictive. The downsides, not many are repairable, and they're usually disposable. That's how it is, guys. Yeah, I told you, Gen 4 is less and less repairable. Gen 5, not repairable. Unless you use like garbage parts and you scavenge from another device, they're usually not repairable. In fact, most of them break themselves when they open. This phone is a perfect example of a Gen 5 device. It only works when it's connected with the internet. You ever tried to use a phone without the internet? Like, not only does it have a fraction of the capabilities, but your phone acts like it's stupid. And it, like, the app that doesn't require internet takes forever to load because part of your phone says, I want the internet. And it's like, no, you can't have it. And that's the crazy thing. You need the internet for many of these things to work, but even if you aren't using the internet, um, some of these devices will operate less effectively without it, like speed wise. So many of them are not repairable. In fact, almost none of them are repairable. And most are battery powered and portable. All of them. All of them are battery powered and portable. And these ones here usually use micro SMD PCBs. Micro SMDs, oh, well, they kind of look something like that. In fact, it's so small that it's so hard to get in there and even switch out components because they're so tiny. They're tiny, I tell you. Look at that. You can't even see it. It's so tiny. See that? There's like 1,000 components right there on that board, and you can't even see them because they're so small. So micro SMD PCBs, printed circuit boards. So guys, now that you've heard the description of Gen 5, let's go ahead and take a look at some of those products. Gen 5. Gen 5, guys, it is exactly what you thought it was. Smaller, less repairable, internet connected devices. This is such a perfect example right here. If you guys haven't seen AEDs, they're large, usually cumbersome. This guy right here that's almost real life size right there. Like what, 4.5 to 5 inches, something like that, square. They're tiny. And they got little consumables that put on your body, and it monitors itself through a phone app and can notify you like, hey, this is the condition of the patient. So actually, responders and stuff could even see the ECG trace and the amount of shocks and stuff you're giving. They could see it remotely. How about this? There's even a little guide on that app that shows you how to give CPR. Let's say you've never given CPR before. Well, there you are. It can guide you through it step by step. How crazy is that? When you start incorporating apps with devices, the flexibility and the resources are just through the wall. So look at this right here. You have 911 dispatchers that can instantly be connected to you with this app. Well, how crazy is that? So this little AED right here. So the way that this one works is if I were to have one here in my office and their 911 says we got an emergency around the corner, you can see right here, here and here, then my AED will alert here in my office and it says navigate to emergency, and it will, like a GPS, show me where the person is. You can see the little map right here, so that my phone will pop up like this. It says 2 AEDs alerted, wait for help and begin CPR. In other words, there's 2 people in this city that have that AED, and it says run, help them. And so if you're in an office building or something like that, this is a crazy awesome product. Again, you have to buy into the service because somebody's got to pay for the servers and the people sitting there watching to see if there's ever an emergency. So there you have it. You have to buy a service in order to have functionality, but at the same time, it is an AED and it is smart. It uses a cell phone app, Gen 5. ECGs, portable ECGs. There's a whole variety of these. Now, one of the things to notice about these small ECGs is that they're almost always 2 leads. And when they're going from here to here, across the heart, it is lead 1 configuration. So when you're using like the little gripper ones, like this one here's got a spot on the side, that metal bar. So you're supposed to hold it with one hand, and the little other thing, you grab it with the other hand. So you're going across the heart. It's a lead 1 configuration. But that still is enough to give you an ECG trace, although maybe not as accurate as some of the other ones. Doesn't have to be in order to get you an instant checkup. So here you can see it's giving you your pulse rate, and it's giving you a pretty good ECG trace right here. And it can also detect things, which is really cool. So if you have a heart murmur, if you got racing heart, tachycardia, bradycardia, whatever it is, this guy here will be able to pretty much see it. And the cool thing is it can record it at the moment it's happening. So if there's other components to this, like let's say for diet reasons, or maybe you're exhausted because of temperature, or maybe because at a certain time of the night it's happening to you. These things help people diagnose what's going on with you because you can accurately have a result, a diagnosis, the moment it's happening, which is the cool thing about Gen 5. All right, this is a Gen 5 product. Again, it has an app. I don't know if you have to buy into the service in order to utilize it. I would assume so. If there is ECG like recording and it sends it off to your doctor, you almost definitely have to in some way pay for that, maybe through medical insurance, but somebody's got to pay. Here's another one of those portable devices. Again, you can see the metallic strip right here along the side. That means right here, see the other little arrow? That means that there's another one on that side. So you hold it like this. Again, lead 1 ECG. And but this one here, notice it's also got a 3-lead ECG option. Pretty cool. So you can either do lead 1 through the 2 sides, or a more accurate 3-lead with, this looks like a 3.5 millimeter stereo jack right here. So pretty cool little device. Maybe I'll get one and I'll have it here on the channel, but definitely a Gen 5 product. This is going to change people's lives, folks. So this one here is GluTrack, and there's a couple of these that I'm going to show you. It's glucose monitoring, an active glucose monitoring at that. So normally you treat your diabetes predictively, like you know your diet and you try to keep as normal and as boring of a diet and routine as possible. That way there you can give insulin injections routinely, certain time, certain day, etc. With active glucose monitoring, your body is not always the same. It's different when you sleep. It's different when you wake up. It's different when you want pasta. Okay. So active glucose monitoring, it's going to be able to change people's lives because you can actively see where your body's heading on trends based on your regular diet, exercise, etc. And you can consult the doctor if you're starting to feel tired one day and you see that you got low blood sugar levels, or if you're starting to see like maybe a speeding heart or fading memory or something. Those can all be sugar related or glucose related issues, and you can see it as it's happening. How cool is that? And you can also administer select quantities of insulin based on what you're measuring. Instead of just giving yourself maybe too much insulin, now you can measure it and accurately administer. Very cool stuff. Here's another one of those little portable ECGs. This one here is another handheld unit. You can see it gives a BPM. It does have a phone app because you can see the phone up here that's monitoring. And it says it's taking a ECG trace every 10 seconds. And you can see on this QRS complex that there are some anomalies there. This person is not in a good way. A little bit of a murmur or something there, because that is not a regular QRS complex, all right? So this guy's got something going on. Probably a good thing that this person would have this as a wearable device, and it's always going to your phone. So if the device detects a problem, I would imagine it's going to contact somebody through your phone without the user to be interacting with the device, which is pretty cool. Now, again, I'm surmising that. I don't really know, but since I see the little picture of the phone, that's what I'm going to assume, that this is an ECG monitor. This one here, you guys have probably never heard of it before. This is the MedWand, all right? And some people might be thinking, that is gimmicky. Imagine a device that can take a variety of parameters and it can transmit those to a doctor live, like as you're doing it. So you can do ear, nose, swab, you can do skin. It's got a stethoscope, thermometer, ECG, EKG. It's got all these features in this one little device. And it can help a doctor remotely through telemedicine. Telemedicine. That's another big one for Gen 5. I should actually have that on the list. Telemedicine. And these products are all basically for telemedicine, so that somebody remotely can help diagnose what's going on with you while it's happening. And it's got a spirometer, so it can measure if you're short on breath, blood pressure. So if you got headaches or something, glucometer, if you're feeling tired. 12-lead ECG on this little guy. How crazy. And weight. I have no idea how it measures weight. But this little device does all these things. It's called the MedWand. And let's see, I think I got some other pictures of it. There we go. So otoscope, ophthalmal scope. So if you got something in your eye or whatnot, dermatoscope. Okay. Pulse oximeter. All right. Thermometer, ECG, stethoscope. Okay. Well, this one little device, which is not very big, it can do all this stuff. This is the future right here. The Med Wand. All right, check it out on your own. Some cool stuff. Ultra Human. This is a ring, guys. This is a ring. It fits around your finger. But notice here, it's got various frequencies of light that shine through. It can do your pulse rate. I wouldn't think that this could do ECG. I could be wrong. I could be wrong. But it monitors your heart rate, and also in coordination with the app, it can give you stats on like how hard your exercise was, etc. Cool stuff. But it's a ring. It's a ring. It's a tiny little ring. You guys knew I couldn't leave this one out. Watches. Now, I myself wear a Samsung. I see that this one here is probably what, for those Apple loving people. The watches can do so much stuff, guys. It does have on the back side, it's got SpO2, and it can measure heart rate and stuff now. Man, these things can do so much cool stuff. And your watch is an extension of your cell phone. They work in tandem, and it is a smart device. That means that it can be predictive, and it can monitor trends. And you can see a trend graph right there. Again, these watches, they're already here. We've been wearing them for years, but it's the future when it comes to telemedicine. The Jazz device. It's a glucose monitor, and this one here works in tandem with your phone. And look right here. It has a little menu. I see it says pasta, light exercise, and it's predictive, and it can also probably help tell you how to regulate your sugar without needing insulin. So some of those people that are borderline diabetic, this here can help diagnose what's going on with you, and at the same time, maybe even give you some advice on what you got to do going forward. Cool stuff. Again, insulin, diabetics, glucose monitoring, big stuff, and it really affects people's lives. This one here, this is a wearable device, and I can see ECG. It's got some SpO2, I think. Looks like, man, I hope that's not somebody's SpO2. But again, Visi Mobile. And some of these ones here, some of the finger cuff ones can also do cardiac output. I'm not sure if this one can, but if it's got a wrist strap and a finger probe, some of those do cardiac output. Not sure about this one. Don't take me on it. And again, there's a service that this is going to be monitored through like a cell phone or something. See how it says Visi Mobile. Cool stuff. They shrank down what used to take a huge cabinet full of stuff, and now it's in a tiny little device. Here's another one of those glucose monitoring strips. You pop it on your skin, and through miniature perforations, it can monitor what's going on with your skin and give you an accurate glucose percentage live. Look at this one, Freestyle Libre. Again, another glucose device. And this one's been out for a little bit. You got a spot right here for blood strips, but you don't need to prick yourself anymore because the Libre are these little pads that you stick to yourself in inconspicuous locations, and they're good for X amount of days, and they will give you a live update on what your blood sugar is. Pretty cool stuff. This was one of my first experiences with a Gen 5 product. Like I said, the Libre has been out for a little bit, but man, talk about changing people's lives. Some of these consumables can be kind of pricey, and that's something to expect with many of these devices if they take consumables, especially with like glucose monitoring. Everybody knows it can change people's lives, but at the same time, if it can change people's lives, that means it can be expensive, right? So Gen 5 product right here. And guys, I think that wraps it up. Holy cow, I know that this was a big video, and editing this is going to be real fun, I'm sure. But guys, I wanted to produce this video for last several years, and in my count, there's about 5 generations of electronics, as we know, and these were all just examples that I came up with. It's my definitions of each one of these generations, and in doing so, you can see certain trends. Now, going forward, you're going to start opening up devices, and you're going to be like, huh, he's kind of right. This is like one of those previous generations. And there's going to be certain trends. Now, overall, things have become more safe, but at the same time, they become less repairable. So that's something to take into mind, but it is what it is. That's the future, and that's the way things have gone. So that is the generations of equipment, electronics, and I would like to thank you for watching.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.
I'm here to assist you with all your test equipment needs, from multimeters and test weights to patient simulators and X-ray analyzers. If you need guidance or you have any questions, please don't hesitate to write me at jbarber@bcgroupinternational.com.